to talk about similar polygons today. All right, so similar figures have the same shape, but not necessarily the same size. Okay, definition. Two polygons are similar if corresponding angles are congruent and if the lengths of corresponding sides are proportional. So we have to have the angles be equal, but the sides be proportional. So here, this is the symbol for similar. So ABCD is similar to MNOP. And you notice here that if I look at this, I have 4 to 6. Okay, that's 2/3. 4 to 6 is 2/3. 2 to 3 is 2/3. 6 to 9, 2/3. So all my sides are in the same proportion, and then all the angles match up. So this tells me that angle M and angle M, A and M are congruent. B and N, C and O, and D and P are equal to each other. And the ratios are going to be equal. So all these proportions are the same. Okay? A scale factor is the ratio of corresponding linear measurements of two similar figures. Okay? So now when we're looking at this, the scale factor here of A to B is 3/2. If I went the scale factor of ABCD to MNOP, it's 3/2. If I say MNOP to ABCD, it's going to be 2/3. Okay, so now I have ABCD is similar to RSTW. Okay, what are the pair of corresponding angles? Okay, so we want to write our corresponding angles here. So now I have angle A is equal to angle R. I guess we could say congruent. Angle B is congruent to angle S. Angle C is congruent to angle T. And angle D is congruent to angle W. Right? Because remember, similarity requires congruency in our angles. What is the extended proportion for the ratios of corresponding sides? Remember, extended ratio means more than 2. So if I said AB to RS is equal to BC to ST, which is equal to CD to TW, which is equal to AD to RW. That is our extended proportion for the corresponding sides. Okay, so here we're going to continue with our example here. Okay, what are the pairs of congruent angles? So now we're given two sides, so we want to write those out. So angle D is congruent to angle S, angle C is congruent to angle R, angle A is congruent to angle P, and angle B is congruent to angle Q. Right? So corresponding angles have to be congruent, similar triangles or similar polygons. Okay, we're going to do the same thing we did before, but now we're using our diagram and we're matching it up. So we go AD to PS is equal to DC to SR, which is equal to CB over RQ, which is equal to AB over PQ. Now, could I have flipped these and said PS over AD, SR over DC? Absolutely. They still are going to give me the proportional. Okay. All right, determining similarity. Okay. So, can I tell if these are similar? Okay, so the first thing is are the polygons similar? If they are, write a similarity statement and give the scale factor. Okay? So when we're looking at this, the first thing I need to do is check my corresponding angles. So 45, 105, 120, 90. Perfect. So far, so good. Now I need to check to see that all my sides are in proportion. So if I put the larger to the smaller, I have 110 over 11 I have 15 over 150. I have 4 over 40, 8 over 80. Are these all the same? So, oops, I flipped these. Let me flip this one. 11 over 110. Are these all the same? So if I were to simplify this, this gives me 1/10, 1/10, 1/10, and 1/10. Awesome. Now I know they are similar. So when I write my scale factor, I'm going to put this polygon to this polygon. So I'm going to go A, B, C, D is similar. Now I need to keep my corresponding. So W, X, Y, Z, and then my scale factor is 1/10. So this is 1/10 the size. Okay? All right. Now we're going to use similar polygon to find a missing value here. So I have X, I have Y, and I have Z. Okay? So these are similar polygons. Okay? So what is the value of X, Y, Z given that these two polygons are similar? MNPQ is similar to RSTU. Okay? So the first thing is M matches up with R. Okay? So now I'm just going to put my X, Y, Z here just because I want to have them listed there. So I don't have to always find X first, then Y, then Z. I can find whichever one's easiest. So M matches up with R. R is 115, so M has to be 115. So Z is 115 degrees. All right? Now, I need to find X and I need to find Y. So I do have this 18 to 30. So I have 18 to 30 equals, and I'm going to go ahead and reduce that. Okay, so this is, if I divide both of them by 6, I get 3/5. That has to equal X over 25. Okay? And now what I'm going to do is I'm going to do a little cross multiplying here. So I'm going to go 25 times 3 is 75. I'm going to go 5 times X and get 5X. And now I'm going to divide. Divide this by 5, divide this by 5. X equals 15. Okay. So X is 15. Now I need to find Y. Y is here. So now what I'm going to do is I'm going to go 15 over Y equals 3 over 5. Well, this gives me 3Y equals 75, or Y equals 25. You probably caught that right away. Hey, if this is 15, this has got to be 25, right? Because we just did that one. All right? But that's using proportions and similarity. Okay. So here's our next one. Okay, your class is making a rectangular poster for a rally. The poster's design is 6 inches high by 10 inches wide. The space allowed for the poster is 4 by 8 feet. What are the dimensions of the largest poster that will fit in the space? So what we're looking at is we're looking at expanding this out to the point where it doesn't distort. So we may have 4 feet by 8 feet, but it may not fit all the way in there. Okay, so we wanna know how big a poster we can have. Okay, so when we're looking at this, we have inches here and we have feet here. So we want to just convert to whichever is the easiest. I'm probably going to convert this to be inches. So this is 48 inches and this is 96 inches. And so now we're going to kind of look, and we can then convert back to feet to kind of give us that idea. So if I find, remember I'm going to draw my poster here. So I'm 6 inches here by 10 inches, right? And I want to find out how big this is if this is 48 inches by 96 inches. Can I extend it all the way to the 8 feet? Will that give me my whole distance down? or am I going to have some issues there? Okay, so at 10 inches, I could go ahead and if I extended this out all the way, I could expand this out by 9.6, right? 10 times what gives me 96, 9.6. But if I do that to match up with this side over here, I would have to take 6 by 9.6. And 6 times 9 is already bigger than 48, so it's not going to fit going kind of diagonally and fit in that space. So we need to kind of look at it. So probably the easiest way is now let's look to see if we can encompass this whole width here. What am I going to miss over here? What's my largest size? So 6 goes into 48 8 times. And so I know that this is going to be 8. So if I made this, if I extended this out, this is going to be 48 inches because this is 6 times 8. So then I have to extend this out by 8 or make this 80 inches. Okay? So now I have my dimensions. I'm 48 inches by 80 inches. If I want to convert that into feet, I can, because this is going to be 4 feet. Okay? Let's see. 72 is 6 inches. So this is going to, 6 feet. So this is 6 feet, 8 inches is going to be my dimensions. I could put this in just terms of that. So 4 feet by, so this 8 over 12, which is 2/3. So 6 2/3 feet. All of them actually are the same thing. They're all equivalent. Okay. Okay. A scale drawing is a similar image, typically smaller, of a real object, where the lengths are proportional. For instance, if you look at a map, if you look at blueprints, a lot of times you can see the blueprints. They're going to be smaller because you have to be able to move them. They're not going to be the size of the house. So you can see schematics of engines and things like that. Those are all scale drawings. They're all drawn to represent. The scale is a ratio that compares each length in the scale drawing to the actual length. Okay. Why did the tomato blush? Because he saw the salad dressing. What did the dog yell when it saw the pieces of the fallen tree? Bark, bark. All right. So similar polygons utilizes proportions. Okay, ratios and proportions. Remember, similar polygons have to have the same angles and proportional size.